Hello everyone. So as promised in the classroom, I will be recording some videos for you to if you have something to utilize for the preparation for the upcoming semester 1 exam. So in this video, we'll be doing theory questions. Now in this theory questions, it will be in the section B of the test. Please answer all questions. Write your answer in the space provided for each question or part question. Try answering all the questions, and of course show your workings where necessary, and all workings should be done on the question paper itself, and always use appropriate units. The number of marks for each question for each question or part question is shown in brackets. So as mentioned, in the classroom you will be these are the questions that I have given you for practice, and I will be discussing all the answers. So uh, question one, element X can undergo the following physical changes. So we have solid X going to solid X, then solid liquid X, and then gaseous X. Now we're discussing the physical changes that is happening for solid X to liquid X. One, all right, we can say that this is what we call melting. Okay, we have melting. Then liquid X to gaseous X to liquid X. Number two, from gas to liquid, we call this as condensing. Okay, condensing. And then liquid X to solid X will be freezing. All right. And last, liquid X to gaseous X, we call this as boiling. Right. Another word for boiling could be evaporating or evaporation. Okay, evaporating. Okay, let me just put that one here. All right. Now for letter B, the question is asking us one difference between boiling and evaporation is the rate at which the processes occur. State one other difference between boiling and evaporation. So this is very conceptual. So state, be mindful of the command words. So as far as I know, we can say that boiling happens. Boiling happens at specific temperature. At a specific temperature. So just like when we say boiling point of water, pure water, it's actually 100 degrees Celsius. It's specific. While evaporation can happen in many different levels of temperature. So maybe this one will do for me. Specific temperature it happen, and then another reason for letter B, we can say also that evaporation happens over a range of temperatures. You can write that down. Also, evaporation can also happen on the surface of a liquid only, while boiling happens throughout the liquid. Alright, I hope that's clear. For question C, element X undergo the following physical changes. Describe the separation, arrangement, and motion of particles of element X in the solid state. Now again, the command word here is describe. Okay, describe. It's just normally this one is a 3-mark question, and just be more specific. So to describe the separation of element X, the arrangement and motion of particles of element X in the solid state, remember, it's specified here, it's solid state. It's not liquid state, it's not gaseous state. So it's just liquid, solid. Now, separation, I would say the separation of the particles in a solid state are actually touching each other. Okay, we can write it down here. Particles are touching. So again, you're describing. So mention particles. You can just say, you cannot just write down touching, but since we're describing, the particles are touching, something like that. And in terms of arrangement, since it's a solid, remember when I've asked you to draw the particles of a solid, usually what do you call this? Usually it looks like this, right? The particles are actually connected to each other. Okay, connected to each other. And something like this. This one might look like a liquid, but particles are arranged in a crystal lattice formation. Alright? Crystal lattice formation. Normally you can erase this one. Wait. If you still remember, it should look like this. Okay? That's how particles in a solid looks like. So we can say the arrangement is, they have a regular arrangement. Okay, particles have regular arrangement. Okay, have regular arrangement. Regular arrangement. Let's transfer this one. Regular arrangement. Another way is arranged in a lattice formation. Okay, you can write it down, arranged in lattice formation. That's also fine. Lattice formation. Alright, that's another other possible answer. And in terms of motion, they vibrate on a fixed point. Okay, they vibrate on around the fixed point. I would say around a fixed point.